Hello everybody, I am Vincenzo Barba, PhD student in Electrical, Electronic and Communication Engineering. I was born in Augusta in 1997 and I obtained my bachelor and master degree here in the Politecnico of Turin. My research focuses on the analysis and development of GaN-FET-based power converters for electrical motor drives. My PhD is carried out in a multidisciplinary environment inside the Power Electronic Innovation Center of the Politecnico of Turin and in collaboration with Efficient Power Conversion Italy, under the supervision of Professor Salvatore Musumeci and Professor Radu Bojoi. The subject of the research is the low-voltage power converter based on gallium nitride field effect transistors. Normally off device features a low conduction resistance, reverse conduction operation with zero reverse recovery, and low parasitic capacitances, which allows to realize small and high-efficiency converters. My research aims to validate the GaN-FET model, improve the efficiency of motor drive system, and investigate the behavior of GaN-FETs when connected in parallel. Simulations require validate model to work properly. The considered LT-SPICE GaN-FET model combines a physical-based structure with analytical equations modeling the nonlinear parameters. Simulations results are matching with experimental waveforms. Measurements obtained with shunt resistors show oscillations due to the parasitic inductance, while the simulations align closely with the Rogowski-Cole ones. In inverter legs, the time avoids cross-conduction during commutations, but causes harmonic distortion and higher losses. To minimize the reverse conduction losses, at the time control is implemented. It acts differently in the two commutations. The optimal deadtime derivation measures the GaN-FET temperature for different deadtime and load current values. Given a current, the converter sets the deadtime which minimizes the temperature. Results show that switching losses are minimized. The procedure can be easily repeated using different loads. The high efficiency of the entire motor drive system can be improved by selecting the optimal switching frequency. Motor loss factor is measured with LCR meter in a large range of frequencies. Results show that the input power is minimum at 50 kHz, which corresponds to the frequency of the loss factor slope variation. Above 50 kHz, the motor temperature remains almost constant. The low switching losses of the GaN-FET allows to predict the optimal switching frequency from the loss factor measurement and to move this frequency where the motor temperature is constant. Parallel connection of GaN-FETs increases the current capability of the power converter, but the parametric spread of devices and the symmetrical layout leads to non-synchronous switching. The device which turns on earlier and turns off later exhibits a current peak due to the currents of the load and of the discharging parasitic capacitances. Furthermore, it eats up more than the other devices. The switching delay leads to a switching energy imbalance, which increases for higher load currents. For a given number of parallel GaN-FETs, the research findings provide suggestions regarding the admissible switching delay and the maximum switching frequency. Moreover, a board with load current decoupling in layout reduces the unwanted current peaks. To summarize my research findings, first I successfully validated the GaN-FET model. Then I focused on improving the efficiency of motor drive systems. Lastly, I investigated the issues of GaN-FETs connected in parallel. During my PhD, I designed custom boards, I developed strategies to improve efficiency, and obtained new findings by experimental tests and simulations. Thanks for your attention and contact me for more.